Okay, so this video is going to be my initial review of the Orion Delta 3D printer from SeeMeCNC. And I'm very excited to do a review on this particular machine, and I'm really looking forward to using it on my alternative energy experiments, other projects in the future. But before we get to the review, let me go over the 3D printer giveaway that we're doing on this particular video. The guys at SeeMeCNC have graciously offered to do a giveaway on my YouTube channel, and I'm very excited to host that. And the rules are going to be very simple. First of all, whoever gets this will need to pay the shipping on it, and the shipping is going to be the standard shipping price that anybody would pay that buys one of these printers. So if you want to enter this contest and you live outside the USA, if you live in Europe or somewhere else, go to SeeMeCNC.com. I'll put a link in the description on this video. Click the link, go to their website, put one of these in the shopping cart, and check the shipping price. You want to make sure that you're willing to pay the shipping price, whatever that is, wherever you're located, before you enter the contest. As soon as that's cleared up, and if you're willing to pay the shipping, then you're free to enter this contest. We ask that nobody enter more than one time, one entry per person in the giveaway. And that's really the rules, but go ahead and read the video description for any details that I may add there. So let's get on with the review on this 3D printer. Okay, so the 3D printer has just arrived. This is the Orion Delta 3D printer. Just came by UPS, so let's go ahead and open it up here and see what this thing looks like inside. Okay, so I've got it all open here. I've got the roll of filament that it came with, the accessories. I see an SD card in here. I really like the SD card option because that will let me put this up down in the shop, bring down a 3D print on the SD card, and plug it in and print without having to connect a computer to it. Really looking forward to that. So yeah, I'm really going to be interested in looking at the quality of documentation now and seeing how easy it is to set this up. All the documentation is online. Okay, so I'm at the SeeMeCNC website here. And I've just opened the printer, so this is really just the first step, and I want to come here and figure out how to build this thing. So let me check under downloads first of all. I see some manuals. I see an Orion quick start guide. You know what? I'm going to try the quick start guide. Let's check this out. To use this guide, left or right arrow keys. Alright, this looks cool. So I can flip here. If you have any questions. Ha, very nice. So, I don't know if you can see this on the camera. Let me rotate the screen back here. Alright, there we go. This looks like a quick start guide that I can step through here with the arrow keys and go step by step. So, very nice. That's impressive. I'll go ahead and march forward through this. If there's anything out of the ordinary or unexpected, I may stop and document that, but I'm going to just go ahead and proceed here and see what it says to do. Alright, so step 12 is to basically take this in this transport position and bring it down into the print position. And they've got some pictures here that show step by step how to do that. So it looks like, first of all, I bring up one of the arms. And then one of the other arms. And then finally the last arm. And there we go. So that's its actual printing position. Very cool. Okay, so now it's time to try powering up, and the first time I tried to power it up, I flipped the switch and it didn't look like anything was happening. That was because I had not plugged in the cables to the LCD panel. So I've got those plugged in now, it's all screwed back together. Let's power this up and go through the steps here. So it lit up as they say it should. Press on the knob once and turn to select settings. So the control's all done with this one knob here, I guess. Oh yeah, cool. So you can basically turn this up and down, scroll through the settings. We'll go to quick settings. And then they want us on step 15, turn the knob, select home all. So we'll go to home all. Oh, cool, look at that. Within about 5-10 minutes it heats up the platforms and the extruder tip, and it should start a print here in a minute. So I tried to initialize the print earlier and I guess the print was starting, I just didn't realize it. So I got to watching the temperature settings and I can see that the print is at 0%, but everything's heating up. So we're almost up to 200 degrees on the extruder tip now. The heating bed is just at 92 degrees. So any second here we should get the start on a print. Alright, so it looks to me like it's trying to print in midair, which tells me that there's probably a calibration setting that I need to calibrate the distance between the plate and here. So let me just check that out and figure out what may be set wrong on that. Okay, so after trying the print and having it kind of print in midair like that, I decided to go look on the website, and I went ahead and downloaded their manual. And there's a lot of information here in the manual that I've already seen that I went over in the assembly of this. This is a very complete and thorough manual. So I would actually recommend starting with the manual. It's got a lot more pictures. It goes over this little switch that I was wondering about as I was proceeding, you know, the little nut that needs to go on it. It goes over plugging in the LCD screen panel. So it goes over these steps that you could miss following the quick start guide. So I'm going to recommend the manual on this. I'm just going to come down here and sort out the information with the height calibration, and when I get that sorted out I'll go ahead and try starting a test print again. So I'll read through this, catch up on all the details, and be back in a minute. Alright, so this is the section I was looking for, and it's setting the Z height, and it says congratulations, now it's alive. Let's go ahead and print. But before we can print, we need to set the Z height in case the machine was bumped during shipping, etc. And it tells how to use the control panel on the machine to set the Z height. So I'm going to go over that. I'm going to video the process, and let's go on from there. Alright, using the control panel, so let's turn this on. So I'll bring this down closer to the paper. And now I'll go to the fine mode. And that is very fine, I'll tell you. Bring it down, and what I usually do is I kind of grab the paper and I move the paper back and forth, at least on my other printer as I do this, so that I can feel the resistance as I start to touch it. Alright, I'll put it there, so now basically it says to press the button, and then go back and click on set measure origin. I see it right up there, so basically now I'm supposed to go up to here and set this. And that's it. You've set the Z height, and now you're ready to prime the HUD and begin your first print. So let's go back and try that print again. Okay, so we're heating up again here to 218 degrees, and the bed's warming up, and we should be starting a print. So I believe the only issue last time was that I just didn't set the Z height calibration, and that's something I have to do on my other Afina 3D printer as well. Definitely anytime you move a printer or anything, it's good to set the Z height. It's just the vertical height calibration. So here we go. You can see this time it dropped down to the plate as it should have the first time. Let me go ahead and move the camera up in here closer. Get a view as to what's going on in here. Wow. Alright, so I'll go ahead and check on this in just a little bit. We'll go ahead and let it do its thing here for a little bit on the glass and take a look at it here in just a couple minutes. Okay, so that time everything was working correctly, but I just failed to prepare the bed. So they send this Elmer's glue stick here, school glue stick, and Because my other 3D printer prints on ABS, and it prints in a very different fashion onto the ABS with some rafting, I've never had to do this with the glue, but I'm really interested in trying this. For a lot of things, I could actually see how maybe this system would work better, especially if you're printing something that's really thin. Because printing on glass for something thin, I could see this actually working substantially better. But alright, I went ahead and prepped the print surface. I'm going to go ahead and we'll try this print again. Alright, so the temperatures have come up and the print is starting. And this time I see the filament material adhering to the surface of the print bed. So things are now working correctly. We got the Z height calibrated and we put down the layer of glue on the print surface. Very important steps, and it looks to me like this is going to be a successful print. So I'll go ahead and let this proceed. We'll come back to this in a little bit and see how it's doing. Alright, this thing is really fun to watch print, and man, it can move fast. You can see it moving with great precision, and sometimes it will just jump to a new position, and it's very precise. I'm very impressed by it, so really doing a good job here. This is just such a cool looking machine. Really, really slick, really nice. Okay, so this printer really moves right along. I'm impressed, and one of the things I'm very impressed by is the fact that it's printing these overhangs without any support material. It's doing a really clean, nice job. Let me come around here and show you this from some of the other angles. Let me see if I can get the camera to focus there. That is a phenomenal job on the top overhang radius there to print it that nicely without any support material under it. I am really, really impressed. The guys at SeeMeCNC did a great job on this machine. Okay, so the bed's cooling down and I'm going to actually remove this part here. Oh, yeah, that comes off very, very easily. Wow, very clean. I don't know if you can see that in the focus, but that is a clean, clean part. And very, very flat surface. I don't see very much warping. Just the slightest little bit of spin on the object, but overall very flat. Okay, so this is an initial review because I've only had this printer for one day so far, just this afternoon. But so far, one of the things I really wanted to go over on this printer was if it was actually easy to just get up and get running quickly. Now my Afina printer that I've started with, this was a very easy machine to use, and it's proprietary. This is not an open source project over here. This is entirely open source, and I'm really behind the open source do-it-yourself maker movement. I think it's just incredible, awesome thing, really excited to be part of that, and that's where this particular machine has come from. So that's something to take into consideration. That being said, it's usually more difficult to get a machine like this and get up and running quickly. This was a very easy experience. From the time that I opened the box, and I'll go over some of that in the video, to the starting of my first 3D print on this particular machine was just over an hour. So that says volumes right there. Secondly, setting up the software so that I could go from 3D Studio Max or take an STL file that I've created and bring it from my laptop to the printer, that was about another hour's time. So I'd say 2 to 4 hours time, and you can get up and running if you're at all technical savvy, if you're a tech savvy person on computers and electronics. If you're not really into that, if you're not really into computers or into electronics at all, and this is intimidating to you, don't enter your name in the giveaway. Approach this whole thing more slowly and learn some 3D graphics modeling maybe before you dive right into 3D printing. But if none of this intimidates you and this is your kind of thing and you're into this to any degree, I was really impressed with the ease of setup, the ease of use on this particular model, and I'll go over some of that. Some of the things I'm really excited about, if you're printing something like one of these motors, and in the past on my Afina, I had to print just the smallest pieces and connect all the smallest pieces together in a modular system. With this particular printer, I can do a lot more than that. It has a much larger print bed, and it can print up to 9 inches tall. So I could literally print a tube right on this that I could use for, say, the barrel of this motor. So I'm looking forward to that. Another thing I really like about this particular printer is the round print base. You know, over in the Afina I've got this square print base, and a lot of times I want to print a rotor for a magnetic motor or something, and it comes right over here to the edge, and some of it kind of sloughs over or off on the edges, etc. The platform also doesn't seem to heat up evenly. Here at the edges and in different portions it runs much hotter, in other areas it runs much cooler. Inside this heated platform, I see that there's a spiral heating element that spirals down and gives very even heating across the platform. With the few prints I've done, I can already tell that makes a big difference in stopping the warping that can happen when you print in ABS. ABS has some shrinkage on each layer, and as you come up, if the layers on top are shrinking and the layers underneath are cooler, or there's temperature differentials, you'll get a lot of warping on the bottom of your ABS part. And I'm really happy with the bed on this particular 3D printer. I'm also really liking the fact that the bed doesn't move, that the bed is static. It just stays here in one spot and the print head moves. I think that really is a great way to go on something like this. Over here at the moving bed, this works as well, but it seems to me that the print is a lot more likely to get off on the vertical axis than it is on this particular unit. Time will tell. I have not used this unit long enough at this point to talk about durability, but I can tell you, looking inside of it, looking at how it's made, I can tell that this machine is made to last. This is a very nicely constructed unit, and I really expect to get a lot out of this unit before anything goes wrong on it. I've gotten a lot out of this Afina. I've really printed a ton of parts off it, and the only part that keeps going out on it, in fact I'm on my third at this point, is a heating element. They have this little tiny heating element that goes under the heating platform, and man, I've gone through 3 of those so far, and they've been about $60 a pop. So I'm really looking forward to the design on this machine, in which I don't anticipate having that issue happen again. So that's just some of the basic things. I'll go ahead and bring the camera down here and go over a few of the other things as well. Okay, one of the things I really like on this particular unit is having the SD card. It's right here on the side of the unit, and that frees this up so that I don't have to have a laptop sitting beside it. I could work on a project. I could work on this motor, for instance, make a lot of the pieces, put them on the SD card, swing by the shop where I maybe have this printer set up in the shop, and print right off the SD card. That's something I haven't been able to do on the Afina, and I really liked that feature. One of the things I liked about the Afina was the fact that I could print with it disconnected from a laptop. So I can start the print on my laptop, I can disconnect it and print. But a whole nother level beyond that is going to be having the SD card here like that. I really do like all the control of the machine right here. Not only can I print off the SD card, but I can adjust temperatures, I can do all kinds of things right here with the control dial set up. That's really nice. In addition to that, I can control a lot of that with the software that you can install on your laptop. So all of that's really good. Okay, so one of the things I want to show here is on the website. If you go to SeeMeCNC.com and go to the downloads, and I'll include the link to their website in this video description, but go look under the downloads and you'll see they got a great manual, just an excellent user's manual that goes with this printer. But another nice thing that really helped me out, and initially I was using it, then I defaulted back to the manual, and I went back to this for the last part especially. This goes over step by step with this really cool 3D effect here, just step by step how to get your printer set up and going quickly. This was great. I did have to go to the manual for a few details that I didn't quite catch out of this on the actual physical assembly of the printer. But when it got time to installing the software for the laptop, this really got me up and going quickly. I was able to go here, and they actually have the download links to the drivers you need, to the config files for Slicer, all the crucial things. Here's some config files for Slicer for ABS and for PLA. You can load these config files and be up and going in a matter of minutes or hours rather than, I could imagine, days, could you not have this. So I'd say from unboxing to complete assembly of the unit was about an hour. I had this particular part printing within about an hour. and I'll go over some of that in this video. I'd say it took about another hour's time to get this software all installed so that I could go from the laptop, from a part like this, and export the STL file and go through this software here, this Repetier software, run the slicer on the object, and have the object over here on the printer printing out. So I just want to show the extruder piece over here that extrudes the tubing. It's very well designed. Everything is really tight, really polished and finished on this. This in no way looks like anything other than a top of the line commercial product. So okay, so the 3D print project that I want to do this time is a little different than the things I normally do, but it's a project for the wife, and it's very, very practical. I'm going to 3D print the magnetic holder for the door stop on these cabinet doors. And we had this one over here, and with the kids actively closing this, they cracked the plastic. And let me get the flashlight on this so you can see this part. I'm going to take my digital caliper and take the measurements on this part and get a 3D replacement printed up. And that will be a very practical use of a 3D printer. So I've taken all the critical measurements off this particular piece, and digital caliper will be your new best friend if you get into 3D printing. But after getting all of these measurements laid out here and the little indents that this piece can snap into and everything, I've ended up with a part that looks like this. Let me see if I can get this visible on the screen, but this part right here is this actual piece, and the magnet should fit onto here, and this should all replace this piece exactly. And this took me, I don't know, half an hour to model up, and as you get better at 3D modeling, modeling stuff like this will just get easier and easier. So I did have a recommendation to check out Tinkercad. I've not tried that yet myself, but that may be an easy alternative to something like 3D Studio Max. But SketchUp is what some folks use, and I will go ahead and have some quick start tutorials on getting some simple objects made up in software like that. But for now, I'm just going to go over the process of getting this from 3D Studio Max to this Repetier software and running it through Slicer and all of that stuff. So basically, in 3D Studio Max, all I had to do is do an export this as an STL. I already exported it. I'll go ahead and open this software up from scratch, and you can see here this is the software that will actually prep the object, get it ready for the 3D printer. So we go over here, we load that STL. You can see it drop down there. This is our 3D preview window here, and we come over to Slicer. Now Slicer has a lot of interesting settings, and because I have some overhangs here at a 90-degree angle, I decided to go ahead and turn support on. And you can come into settings and adjust support material, all of these basic settings. But I've already got that set up, so let's run Slicer. Now you'll see that Slicer will slice this model up. And what's really interesting, there's a preview here that you'll see in a second. We'll let it open up here. This also prepares the G-code for the machine, so you can put an SD card. But alright, so now you can see this blue object. If you zoom in far enough, you'll actually see that it's made up of individual blue lines. And those lines represent the ABS print feed that comes off the printer, so it's pretty interesting. You can see here that over the 90-degree section, you can see the support matrix underneath that's going to support that up, etc. So that's all ready to go. At this point, all I need to do is go ahead and save the job, and I'm going to save it to this SD card. So let me just go here to the SD card under G-code, and I'll just call it, I don't know, wood, SH for wood shelf. Alright, that's saved, and now we'll bring that over here to the printer. Just back this off here a little bit. So just put the SD card in the printer, and let's go ahead and flip this on. And while I cycle through here, I'm going to go ahead on quick settings and do a home all and a preheat ABS. we'll go ahead and go to SD card, print file, G-code, and we'll go to wood shelf. That little high-pitched cricket sound that you heard, that cricket sound actually means that the file is loaded up and it's getting queued up for printing. And you can see the temperatures warming up here. And it'll be a few minutes before this is ready to go. So you can see the temperature here is at 53 and we're shooting for 90. And you can also see the temperature on the print head over here. It's got a printing percentage to complete. A lot of nice information. You can scroll through some of the other stuff in here. Okay, so let's get the piece here off the print platform. There we go. And I'll remove the support material here, which I've never tried on this particular machine. Oh wow, that came off very easily. A few loose strings here on it. Alright, they seem to fit very nicely. So this is a great example of something that you can do in 3D printing that, you know, could really be a pain otherwise. I don't even know that if we could find this particular part for that cabinet. You know, my wife has been asking me to get this thing replaced, and if I didn't have a 3D printer that could be a real pain. But now that I've got the 3D file, should others break in the house, you know, if we get more furniture that has this same part, or if any of the rest of the furniture has this particular part, I've got the file now. I can print another one. So let's see if this snaps into place here. Aha! Listen to that, folks. So if anybody happens to have the same magnetic holders and needs this file, let me know and I'll upload it up onto the laserhacker.com and you can download it from there. But okay, so this 3D printed piece is in place and it seems to be a perfect fit. It seems to work really well, holds the door fine. So that's just a great practical use for 3D printers, replacing broken pieces that would be hard to find, hard to order, and it's very simple, makes the wife happy, and it's just one of the many uses of a 3D printer. So okay, so I also want to try printing some of these little qubits. These are a small block that I've designed, and they allow you to kind of build like Minecraft in the physical world. And they just snap together. They're kind of fun. I designed them and have been printing them on the Afina. They're pretty small, and they have a very interesting interlocking system that requires a lot of precision, especially this size, to print. And they're kind of a pain to print on a perf board and to try to separate off, so I'm going to try printing some of these blocks just more of it as a precision quality, a small size test on this Orion Delta printer and see how they do. But let me just show the action of building something here with them a little bit so you can see how they work and what they do. You can snap them into each other in any position and come off at any point with something like this. So that's the basic idea. So I'll rapidly build something up here. I did a few little trees and things. This is really just for the kids. A lot of fun to play with. Okay, so first of all I need to load one of the 3D models for these little blocks into Repetier. And I'm going to go ahead and do that. I'm going to show you some really cool features they have here. So this is one of the blocks. You can see it drop down there. So now it's down here at the bottom of the plate, the printing plate. There's one brick. Over here on this side I can delete it. I can do a lot of interesting things. Like I can copy it. And I can put how many copies I want. So I don't know, let me try doing let's say 9 copies, and it'll populate it across the board. That's very nice. That saves a lot of time, and it spaces them very nicely as well for 3D printing. So Okay, so I thought this would be interesting to show a side-by-side comparison in the operation and action between different 3D printer designs. And you can see that on this one, the bed itself moves back and forth on this axis, and then this moves up and down on this axis over here, whereas on this one it's a completely static bed. Now, one thing I'm doing on the Afina right now, I'm printing some of these same bricks, some of these little guys, in PLA. And I just want to show an issue that I've had in trying to print in PLA on the Afina, and I've tried every setting I could come up with. Let me get back here and get this to zoom. As this prints out, you'll see a bunch of like spiderweb stuff forming between the PLA parts. And it gets so bad that it makes most of the parts actually unusable, or it can take a very long time to remove all these spiderweb fragments. So I thought I would print 4 cubes in PLA on this machine, print 4 cubes in PLA on this machine, space standard settings between both machines, and just see how the cubes turn out. So that ought to be a pretty interesting test. I will say right now in the Afina that 2 of the fan blades on this little fan broke off. One time when I reached up here and the fan blade was running, my finger hitting the fan blade actually broke off the fan blades. I'm not able to find this fan part right now. If anybody out there in the Afina world can tell me where to buy that fan, that would be awesome. I may just have to spec it aftermarket, but so far I've not been able to find that. I did send Afina an email here a while ago, and they've not responded to me, so I don't know. I'll just have to try to hunt that down. But I do have high hopes that with this being an open source project, that any parts like that ought to be a lot easier to source with an active forum and an active community. I believe that the printer this is based on is part of the UP printer line. And I know the UP community has a fairly active forum with a lot of users and a lot of help, but unfortunately I've found no community support or forum for the Afina. If anybody knows of one out there, let me know, because I do plan on keeping this printer and using it alongside this one. But I would love to be able to get parts for it and to find an active community supporting this printer. So anyway, so here they are. The blocks are finished, and they look really nice. I'm going to take them down here and see how they interlock and connect in with the existing ones that I made, but they sure look good at first check. So these pieces seem to interlock very well. They're a nice fit. They're a little bit loose on the connections, but that's probably just a minor setting. On the Afina, they're a little bit tight, and initially they're really hard to get together and join and separate. And on the Orion, it's just they're just a slight bit loose on the connections. So I would need to tweak the model just a little bit to get it just the way I like it. But that's normal between printers. So overall, I really am impressed. I love the fact that they interlock with the red blocks so well right off the bat like that. And let me show you what I mean. There you go, and put a tree down over here, and you got the beginnings of a little game level or something going on. So pretty cool. Definitely they seem to be working correctly, so that was a great test print for a precision, small scale precision test print. Alright, so far the print's looking really nice. Now I did have to stop the first print and start another one because one of the little blocks tipped over. And I think that's because I had not put down a fresh layer of hot glue. I was trying to print on top of a previous print. But one of the blocks tipped over, so I started the print again, and when it printed the outer ring around it, there was something kind of hokey about it, so I took some tweezers and just pulled it off, but that's the reason you see no outer ring this time. But anyway, I put down some fresh hot glue. They seem to be holding fine, but the most impressive thing to me is I see none of that spiderweb action. That's really what destroys my ability to print with PLA on the Afina. PLA is a very rigid material, and I really wanted to be able to print with it, and it looks like now I can. So I'm looking forward to doing a comparison when these are finished on the PLA products. But anyway, we'll check back later. Okay, so it's just finishing up, and I'm just very happy with the look of that. So we'll do a comparison now. Okay, so here's a comparison between the objects, and let me come over here. You can see the roughness on the surface of these. I broke this one loose earlier, and this roughness keeps the little grooves from sliding into each other and keeps the blocks from interacting. I still got it in the heat bed over here, but let me come over and show you what came off the Orion. There is a little bit of spider web string stuff, but it's so fine and it's so light I can literally just break it away. So I've got very high hopes that these are going to work correctly. I'm going to break them off here and take a look at it. Okay, so this is a very interesting comparison. You can see that the ones off the Orion here just printed correctly the first time with the PLA config file that Orion or SeeMeCNC provides. They actually fit together, interlock, and you know, they just function. They just work. So I'm very, very impressed by that. This is actually the first successful PLA printing I've done in something like this. I have been able to print like a perfectly round rotor if it doesn't have any details in the past with PLA and the Afina, but when you end up with a result like this, you know, I'm not even going to remove the rafting on the bottom of these because I can just tell these are not going to fit together. These are not going to interlock. So my concluding thoughts on this printer are that, you know, I've had, I don't know, 5-6 hours playing with it through the night last night. This is a great 3D printer. I'm really, really happy with it. I can't wait to see how it holds up long term. But so far, I'm just very happy with it. I really like the quality. The fill and the finish on the parts is great. Very happy to be able to start printing in PLA. And I'm looking forward to printing in T-glass. You know, I want to print a lot of my alternative energy projects, my electric car motor parts, etc. And I've been looking for a good, strong material. And this T-glass, as I understand it, this is very similar to the stuff that clear plastic water bottles are made out of. Very, very strong material. So this is great when you're creating something like a rotor with magnets in it and you don't want to fly apart at a high RPM. And I'm really looking forward to having the adjustability of temperature controls and platform controls so I can print in materials like this and get it correct and not have to be reliant on adding boards of resistors and switching between resistors and things like that. So overall, so far it's been a great experience. It's definitely something that somebody can tackle as long as they're not intimidated by computers and electronics. I don't see any reason somebody couldn't learn to use one of these.